Okay, we'll be
Homework.
doing we'll do our homework on the function substitution. But before we get to that, I want to look at just a review on mapping using maps and using tables of functions.
Yeah, I told you the one with the circle was D. And you tell me no. I know I was right because that's the first one to pop out. That circle thing, I told you it was D. The one with the circle, the
Yeah.
6 circle. I think that one was D. The first time you said it was D, and you said no.
What, on your
And I
homework?
said it was D.
You had a map on your homework? I thought that no, the homework didn't have maps.
No, the one where we did before where it's a correction. It takes me as a correction for the paper we was doing last week, Monday.
Oh, okay.
It says A, B, C, D, and I remember I was telling you that the maps was that round circle thing was D.
Okay.
Yeah.
Well, I want to look at, let's see, I think it's, no, that's not the one. That's going to be a homework. Map it. But I want to do, let's see, that was the homework that you had. Continue review. Okay, here we are. Mapping functions. This is review of something we went over, but since I'll be giving you some homework on mapping, I thought I'd go over it again. Now, you see mapping functions, you see this screen?
Yeah.
Okay, now, you see a map here, you have A, and you have elements A, B, C, D, and you have B map D, E, F. Now, for something to be a function, all the elements in one map must map to the next map. So if you have something that doesn't map to it, then it's not a function. So would you say this is a function, this first one? Latoya?
Yeah.
Would you say this is a function, this first map?
Yeah.
Why? Why do you say it's a function?
I never could say why it's a function. I'm just guessing.
But remember I said every element in this map, say A, must map to something in B. So does everything in A, every element A, B, C, D maps to something in B?
Every element. That's what it's every element in A.
In A, right here. This
must match.
Must map, not match, must map, M-A-P, to something in B.
In B.
In other words, every element in A must have an image in B. Is that true for this first one?
Must have an image.
You have four elements, A, B, C, D. Does each of these
Only see two.
You don't see A, B, C, D?
No, it's only two I see.
Okay. Now do you see it?
No. It's only 1, 2 I see.
You don't see A, B, C, D, and A?
No.
What do
I don't see that.
What do you see, Latoya?
I don't see state whether each relation represents a function. And it's 4 circles only. That's it. It's 1 and 2. That's it.
You don't see mapping function?
Yeah, function / mapping, yeah.
Let me do a new share. You see it now?
Yeah.
Mapping function?
Yeah, I see it now.
Okay,
I didn't see that before.
Oh, okay, that's I did a new share. Maybe I wasn't sharing it. Maybe I wasn't sharing my screen. Now, what I said is for it to be a mapping function, every element in A, that's right here, must map to something in B. If that doesn't happen, then it's not a function. So my question, Latoya, is does this represent a function?
No,
Why?
because it's not, it doesn't have the same image as, A doesn't have the same image as B. D is left by itself.
No. These lines represent the mapping. In other words, A maps to D, B maps to E, C maps to F. Now, D is not mapping to anything, so that's why this is not a function. Because
Yeah, that's why I said D is on its own.
yeah, that's right. It's not a function because D is not mapping to anything in B. So every element in this circle must map to something in this circle. B. So this does not represent a function. Got it?
Yeah.
All right. Now, let's look at, okay. Now, let's see, I think my next one is, okay. Now, does this represent a function? Each element in A must have only one element in Y, okay? So, is that the case?
No.
Why is it? You have A, B, C, D, right?
Yeah.
A maps to D, B maps to E. C also
Right.
maps to E, which is okay. Remember, this side, it's all right if we've got duplicates right here. Okay, like B to E, C to E, okay? D to F. This represents a function because A, B, C, D only maps to one in this one. In other words, B maps to E, but B doesn't map to anything else. C maps to E, C doesn't map to anything else in B. D maps to F, and A maps to D. So this represents a function. Got it?
Okay.
It's not a problem that E is the mapping of two functions here. What would make this not a function if I had a B here for the C and I had B mapped to E and then B maps to something else. But if I had a B to E and then a B to the E, that would still be a function because it's only mapping to one output. Okay, so this represents a function because every element in A maps to just one element in B. Got it?
Yeah.
Okay, let's look at, okay. Does this represent a function? Yes?
Yeah.
Why?
It's connected to,
You say this represents a function?
no, it's not,
Why?
because it has two elements connected to the A.
A
To
only
the B, I mean,
That's
to B.
right. That's it, Latoya.
Sorry, to B.
Yeah, B is mapped to two different functions, the only one-to-one relationship. So this makes this not a function. This element in A must map to just one function, each one, like A to D, B to E. We could have B can't. Once you put another duplicate B here, it unless it maps to the same thing over here, then it's not a function. I mean, I could have had a B to E, then I could have B to E again. That would be a function because it's only mapping to one. I just repeated it, all right? So this does not represent a function because B, we call that the input, is mapping to more than one output. B to E, B to F. That makes it not a function. All right. Now let me know if you have any problems with this, because I will, some of your homework, one of your homeworks will be mapping. Okay. Now, if you have ordered pairs, you know when it's not a function because one of your X values is repeated. So like you have an X, Y, X, Y, X, Y. Well, if you repeat the X, then you know it's not a function, right?
Yeah.
This Audrey coming on. And I guess, Chastity, are you driving? Chastity's over, she may be driving. Okay. All right, so now let's look at function tables. Now, function tables, they work just like maps. You still can't have more than, well, if we call this left side our input and the right side
Okay, output.
Okay, now, none of your inputs, if they're duplicated, they must have the same output. So, hello, Audrey.
Hi, good evening, Miss Barbara.
Yeah, we just went over map. Do you understand mapping?
Huh?
Do you understand mapping a function?
It's not yet.
Don't worry, Latoya will explain it to you. Latoya, Latoya, explain this first one to Audrey. Tell her if this is represent a function or it does not, and tell her why.
So the A is the output and the A is the input and the B is the output.
That's right.
So if we make it an element, A must be an image of B. So A is connected to D, and B is connected to E, and C is connected to F. But D is by itself, so it's not really a function.
Yes, did you hear that, Audrey?
Yeah.
Latoya explained it to you very well. Every element in A must map to something in B. And since D does not map to anything in B, that means this does not represent a function. Got it, Audrey?
Yes.
Okay, now let's look at the next one. Okay, what about this one, Latoya? Explain this one. Does that represent a function?
Yes. So
Right here.
this one must have more, it can have more than one element in the mapping function. So A is connected to D and B is connected to E and F. So this is the element. You could have more than one element between the input and the output.
But remember, this can only map to one output.
Yeah, it can only map to one output.
But here you're mapping to E and F. So that means it's not a function. This input B element is mapping to both E and F. Cannot be a function because it's only a one-to-one relationship, one element to one element. Okay, and here you have different ones. You have an E and an F. You follow that, Audrey? This does not represent a function because B is mapped to two different elements in B.
Yes.
Okay, so that's not a function. All right, Latoya, what about the next one? Does this represent a function?
Yeah.
Why?
because it's the input and the output map. The input and the output maps. The input and the output represents a mapping function.
Because what?
A is connected to D, B, C is connected to E, and B is connected to F.
That's right. You don't have a repeated, you don't have like a B mapping to two different ones, right? B is to E, and then C is a different element in A, and it's mapping to E. See, the fact that if they both mapping to these, like this is Y, let's call this X, and this is Y. The fact that it's mapping to the Y, say elements here, is okay. But you can't have like B and then B, and then mapping to two different elements in B. Is that clear, Audrey?
You say I can't have two elements matching to
Well,
one.
you can't have duplicates. In other words,
Okay.
A, B, and then B again, mapping to a different element. You could have B, E, and then you could put B here again and say E, and that would be okay. But you can't say B, E, and then have B, say B, G. It can't be different. Okay, it's only a one-to-one relationship. Okay, it say, like when we said with the XY pairs, it say you can't repeat an X value because then it wouldn't be a function. So if you repeat this B has to map to something different from that first one. Can't be the same.
Okay.
Yeah, I mean, it would be the same, but it can't be different values for the output. So we can determine functions from mapping. We can determine from ordered pairs. We can determine from tables. We can determine from graphs. Because with a graph, if you draw a vertical line and you have an X, well, the vertical is the Y, right? And the horizontal is the X. But if you have the X on different Y values, then that cannot be a function. So a vertical line on a graph is not a function. And that's where we were when you came in order. Now we're looking at tables. Tables really work just like maps. Now, you see this function table here, right?
Yeah.
Now, you see ministers and their office. This table lists the government ministers of the legendary Kingdom of Neverland. Can the government offices be represented as a function of the minister's name? Now, just call this X and call this Y, okay? Now, wherever you see a duplicate, then it must map to what? The same office. So, where do you see a duplicate, Audrey? On the minister.
Wendy twice and Peter twice.
You see who do you see
Peter,
twice?
Peter and Wendy.
You see Peter here. Now, Peter maps the president. Peter maps here to justice. That's different. So Peter is mapping to two different offices. So that cannot be a function. And then you said, what was the other one? Wendy. Wendy maps to the education office, and Wendy in the table also the health. So it's not the same. So that means, can the government offices be represented as a function of the minister's name? Okay, answer.
No.
That's right, answer no. Okay. So you can do this without, you can do it, without it being numbers, okay? And this is kind of a nice way to see it that way. Okay, let's look at another one, another table. Latoya, number 2. Can the total distance be represented as a function of fuel? Yes or no? Can the total distance be represented as a function of u? Now just think of this as x and this is y. Now, wherever you have a duplicate x, if it maps to the same distance, then that's okay. But if it maps to a different distance, then that means it's not a function. So
30 and 100.
Yeah, 30 maps to the distance of 100 and distance 100. So it's not different. So that 30 to 100 and 30 to 100 is okay. What else do you see there? What?
35 and 35.
35 and 35. 35 maps to 120 in the table and 120 in the table. So they are the same. So is this a function? Yes or no?
Yes.
Yes, right. You understand that, Audrey?
Yeah.
Yeah, because even though you got duplicates, they map to the same distance in the table. So that means it's a function. If those distances were different, then it would not be a function. Got it?
Yeah.
Okay. Audrey, number 3, I give you a chance to look at this one. Can the size of a pack be represented as a function? Here's the size, here's the price. Can the size of a pack be represented as a function of the price? So look here, see if you see any duplicates. If you do, see if they map to different sizes. And if they do, then we can't use the size of a pack as a function of its price. So would you say, can it be used? Yes or no?
No.
Why? Why do you say no?
But I don't see anything matching.
What? Why do you say no? Why do you say no? A size of a pack, can the size of a pack be represented as a function of its price?
The function of the pack.
Price. Can the size of a pack, and that's the size right here in grams,
The size of the pack.
can it be represented as a function of the price? Yes or no?
No, because I don't see anything that matching.
But that's not the reason why you said no. Why no, Latoya, you know?
Because the input doesn't match the size of the output. That's what I said.
No. Remember I said like this, you call this X, you call this Y. Now, do you see the duplicates over here on the price side?
Yeah, there's duplicates. $1.90.
Yeah, you see $1.90, $1.90,
$1.90.
and $1.90. Now, are they mapping to the same in the table? Is the size the same for each of the price $1.90?
No.
No.
Where do they differ?
850 and 950.
That's right. $1.90, $8.50. $1.90, $8.50. That's perfectly fine. But look here, $1.90, $9.50. Different, right? So you're trying to map that 190 to both 850 and 950. So can the size of a pack be represented as a function of a price? Answer is no. Answer is no, because you've got price duplicated, but they're not mapping to the same size. Now you have 850 here, 850 here. If this were 850, then it would be a function. But this is a 950. It's different. Got it?
Mm-hmm.
So answer is no. Now, we have a table here. Let me put this further down and I'll bring it up so you can see it. Okay. Now, all right, you have this table and you have some choices here. Okay, look at the table. Tell me whether it's A, B, C, or D. It shows the relationship in this table. Look at the input. Look at the output. What operation do you use to go from the input to the output? I notice your relationships are multiplication, addition, division, and subtraction. Why?
Multiplication.
Okay, multiplication. And what is the multiplication, Latoya?
It's A.
That's right. Very good. You see that, Audrey? Y output.
Where you at?
Number
Cause I
4.
ain't see.
You don't see
Huh?
number, you don't see number 4?
Wait, I must be on the other side.
I'm on the
Yeah,
other
yeah,
side.
over the other side.
Oh, yes, I was on the other side, yeah.
Okay. You see number 4, right?
Mm-hmm.
Now, to get the output, to go from 1 to 3, what do you have to do, Latoya? What operation?
Multiply. 3 times 2 is 6.
Yeah, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is
5, 15.
So you see it's a multiplication. So output Y is 3 times the value of X. And it's greater than 0 and less than 5. That's the input. Because you see here, it's greater than or equal to 0, because you see a 0 value. Less than or equal to 5. So there's your range there from 0 to 5. So an answer A. You see that, Audrey? You see why it's A?
Yes.
Because if you apply Y equal 3X, Y equal 3X, and you apply that to every X value, you will get the Y value that's in the table, right? You get the Y value. Y equal 3X. 3 times 4. X is 4. 3 times 4 is 12. X is 2. 3 times 2 is 6. Questions? And we go to number 5. Over on the other side, I'll bring this up. Let's see. Okay, number 5. Now, we want to know which of the following, of the function tables has a rule Y, that's the output, equal 2X plus 5, where X greater than or equal to minus 3 and less than or equal to 2. So they all follow that, right? But what about the output? Which one of them, if you multiply 2 times X and you add 5 and you get what is in the output in the table? Audrey, do you see it?
Mm-hmm.
What's your
You
answer?
say what?
Yeah. The rule is Y equal 2X plus 5. So multiply 2 times the input, add 5, and you get output. So which one of those tables represent that? Which one represents the rule? Y equal 2X plus 5. Y equal 2X plus 5. That's the rule. Now, which of these tables do you apply that rule and you get what you see in the tables, Audrey? Multiply 2 times the input, add the 5, and see if you get the output. Which one?
have no idea.
But the first one, if you multiply 2 times minus 3, you get what?
2 times 3?
2 times a minus 3. There's the input, minus 3.
Okay.
What's 2 times a minus 3? Audrey, what's 2 times a minus 3?
It's 6.
Plus or minus?
Negative 6.
Negative 6, okay. What's a negative 6 plus 5?
Negative 6 plus 5?
Mhm.
No, negative 6
Unlike you subtract,
is 1.
plus or minus?
Minus 1 is a 0.
No, it's a minus. Negative 6 plus 5 is a negative 1. But the table says a negative 6. So that means A does not match that rule, right? Because when you multiply 2 times minus 3, you get a minus 6. You add 5, you get a negative 1. But the table says the output is a minus 6. So you know that one's not right, correct?
Mhm.
You follow? What about B? Latoya, could it be
It's
B?
C. No, it's C.
Okay, why do you say
I
C?
said C.
Audrey, do you agree it's C?
No, I didn't work it out.
Well, okay, Latoya said C, right? 2 times a minus 3 is a minus 6. A minus 6 plus 5 is a negative 1. So we see that works for this first entry in the table. Let's go to this one. 2 times a minus 2 is what? A minus 4, and a minus 4 plus 5 is a plus 1. So that works. 2 times a minus 2 is a minus 2. 2 times a minus 1 is a minus 2, and a minus 2 plus 5 is a 3. So we see that works. 2 times 0 is 0. 0 plus 5 is 5, right? 2 times a 1 is 2, and 2 plus 5 is 7. 2 times 2, substituting the x, 2, that's 4 plus 5 is 9. So we can see the answer is C. Audrey, you see that?
Yeah.
You don't sound like you're convinced.
But you belong fast.
No, look at the, remember we using this rule, right? So let me just, okay. So we say y equal 2x plus 5. Okay, now if I substitute for x minus 3, right? What would this be equal to, Audrey?
2x minus 3.
Well, if I substitute for x minus 3, so y equal to, now x, I'm putting the minus 3, the input, right? Now plus 5. So that's going to be equal to minus 6. 2 times a minus 3 is a minus 6. Okay, plus 5. And Audrey, what's a minus 6 plus 5? What's a minus 6 plus 5, Audrey?
It's 3.
A minus 6 plus 5? Minus 6 plus 5, you subtract. What do you get?
1.
Plus or minus? Plus or minus?
Plus or minus what?
1. You said 1. Is it a plus 1 or minus 1?
A minus 1?
Yeah, it's a minus 1. Because what? You have more minus than plus. Minus 6 or the absolute value of the 6 is bigger than the 5. So it has a minus sign, so minus, right? Minus 6 plus 5 minus 1. So when we put the minus 3 in, we got what? The minus 1 that the table has, the output, right? That's the Y. Now do the same for the minus 2. All right, let's let me just bring that down. Now, what I want you to do, Audrey, I want you to put the minus over here. Okay, now we'll use the Y equal 2x plus 5 again. And I want you to put the next value in there. Y equal 2x plus 5. Now we did it for the minus 3. Now put the minus 2 in there. And what do you get? For x, you want to put
where?
for the input. See, we did the minus 3 and we got a minus 1 for the output that matches the table. Now let's do the same thing, but let's take the next x value, which is a what? Minus 2. So this will be Y equal 2 times a minus 2 plus 5. That's our rule, right? And what's 2 times a minus 2, Audrey? What's 2 times a minus 2?
It's 4.
Plus or minus? Two times a negative 2. And a plus or minus 4?
I don't understand you.
Well, 2 multiplied by negative 2, right here. 2 times a negative 2. What does that equal?
Right.
2 times a negative 2. What does that equal to?
It's negative 4.
Negative 4, that's right. Now, what's a negative 4 and a plus 5? What does that equal to?
It's 1.
That's right, it's a plus 1. Now, what do you see in the table? When it's a negative 2 input, you get a 1 output. So you see that matches, right?
Yeah.
So every value of input that you put in the rule, you get what the table has for the output. So if you put a 0, that would be 2 times 0 is 0 plus 5, and then the output would be 5. If you put a 1, it would be 2 times 1 is 2, plus 5 would be 7. If you put a 2 as the input, it will be 2 times 2, which is 4, plus 5 would be 9. So you can see that table C matches the rule. That the output is 2 times the input plus 5. That clear, Audrey?
So the input is multiplied by 2?
Yeah, the 2 times the x. See, this input is the x value. The output is the y value. Okay, in the table, input values are x, output values are y. So you put the x value into the rule and calculate the y value. And if it matches what's in the table, then we know that rule holds. Got it?
I think so.
Okay. All right. So let's go to, well, actually, I want you to do some. Should I have you do this one now, or should we do it for homework? Maybe I'll leave this for homework, and we'll go to the homework of today. Any questions on tables or on maps or functions? Okay. Audrey, did you get a chance to look at your homework? Latoya sent me some of hers.
Yeah, I try it, but.
Okay. All right. All right. Let's look. Now this function table number 6, that will be your homework for next time. So we will look at the homework. Let me do a new
Good afternoon,
screen.
everyone. I'm sorry, I'm driving.
Okay, Chastity. Okay, let's look at our homework. Let's see.
So we gotta put in the output for those?
Yes, that would be homework for these
Oh,
tables.
boy.
All right. Now let
You
me.
want for what? The input for what?
Huh?
She said up the input for what?
Yeah, you got the input. You're putting in the output, and here's the rule. The rule is at the top. So like.
So which bracket the X you're gonna put -1?
Like -1, that would be 2 times a -1 plus 13, and that's your y. The f of x is really your y.
2 times a -1?
Yeah.
What she say?
So 2 times a -1 plus 13. And 2 times a -1 is a -2 plus 13 would be an 11. So then you put 11 in the table. Got it? So you plug in the x, solve for the f of x. The f of x is really the y that we said over here, y, okay?
It's gonna be -11 for the first one?
Well, 2 times -1 is -2. A -2 and a plus 13, Latoya, is a plus 11. Because a 13 is plus.
That's what she's saying.
Audrey, you following me?
You're talking a little fast for me.
Okay. Let's take this first table, right? You see the first table?
Yeah,
F of x equal 2x plus 13.
that's fx.
That's the function of x, which is equivalent to y. That's the output. F
So
of
that
x.
is y.
Yeah, well, that's equivalent to y, but in the table, we're calling it f of x for function notation, okay? But it's just like the y we had over here, okay? It's just that we calling it with function notation, f of x. So f of x is your output, x is your input. So you plug in the input in this formula, in this equation. 2 times -1 is -2 plus 13 will give you 11. So that first one would be 11. Latoya, you following?
Yeah.
So what would be the second one, Latoya?
Huh?
What would be the second f of x?
She says.
13?
13. Audrey, you see that? 2 times 0 is 0. And 0 plus 13 is 13.
So that's 2 times.
Yeah,
2 times
wherever you
x.
see the x, you're gonna put the value you see in this column. So 2 times 0 is 0. 0 plus 13 is 13.
This one, this one, when you finish with Baba, this one.
She said 2
4.
times x is what? 2 times.
Yeah, if it's 0 for x, 2 times 0 is 0. Any number times 0 is 0. And then 0 plus 13 is 13. So the f of x for 0 is 13. Now, Audrey, what is the f of x when x is 1? What would I put right here in the table?
2.
No. 2 times 1 is what, Audrey?
2.
And what's 2 plus 13?
Oh, I didn't add the 13.
Gotta add the 13. That's part of your f of x notation. So 2 times 1 is 2 plus 13. What is 13, Audrey?
15.
Okay, 13 and 2 is 15. Now, when it's 2, what would f of x be?
4 and 13 would be 17.
That's it. What about when it's 5?
2 5 is 10 and 13 is 23.
That's it. You got it. That's how you finish the table. You
Miss Baba, number 4.
But how if you
You have X outside. What's that about?
What, the X times the 3X minus 4?
Mm-hmm.
Okay, that means wherever you see the X, you want to put a minus 1. So you'll have a minus 1 here, and you'll have a 3 times a minus 1.
Oh, because I
Got
didn't
it?
understand that one.
Yeah, you wherever you see an X, you put a minus 1. So this will be minus 1, parenthesis, 3 times a minus 1, minus 4, and then put the result there.
3 times a minus 1.
Anyway, you see X.
3 times a
Wherever you
minus
see an
1.
X, wherever you see an X, you're gonna put the value of the X. So for here, X is a minus 1, both here and here. The X and the 3X. And for the 0, X, you put 0X, 3 times 0. And so that's 0, 3 times 0 is 0 minus 4, and 0 times anything is 0. So that'll just be 0. Right?
And this one is a minus 8. So anytime we see, we just put minus 8 times the input.
You mean here? No, X minus 6. So minus 8 times a minus 6 would just give you 48.
X.
Because that's a multiplication, right? Got it? So wherever you see an X in your function notation, you put the value from the table of the X and then calculate the output that we call an F of X.
Wow.
Got it?
And then number 7, which part we see X, we put a minus 4, a minus 3, a
Yes,
minus
that's
6.
right. 10 times a minus 4, and then add the 17. 10 times a minus 3, then add the 17. 10 times an 8, and then add the 17. Got it?
Yeah, I guess so.
Okay, any questions? Because that would be your homework.
Okay,
Complete
10 times the-
Complete this table. Audrey, any questions on how you'll complete your table?
I ain't sure. I'm not
What did
sure.
I do on the homework?
I sent you the results.
He said
Hmm?
Fx,
I
Fx.
texted you or either I emailed you the results.
So the x equals negative 8x. And she said where the x is.
The one where you
Yeah.
said negative 23. I had the
Negative
negative on my
6.
paper and I put on the
Negative 4,
I gave you credit for it. I figured you just made a
Negative
mistake.
Oh
1,
my God.
Yeah.
2, and 7. Where the
Audrey,
x is.
Audrey, you
Huh?
understand what you have to do here? Any questions on the table?
I'm trying to fix it now. We're trying to understand it right now.
Yeah, you substitute in this f of x equal equation the value of x from the table. Where we see x, you're gonna put the value there and then calculate what the function notation f of x is, which is your output. that
So
we
the
call
x-
by-
Okay, so it'd be 3x. Oh boy.
Like this one, it would be, say it was a minus 1, right? Minus 1, parenthesis, 3 times a minus 1, minus 4. And whatever that value is, you put it here.
3 times a minus 1.
Yeah, because x, 3x is 3 times a minus 1 when x is a minus 1. So that would be a minus 3 and a minus 4 would give you a minus 7. And a minus 1 times a minus 7 would just give you 7. Got it?
So confusing to me.
No, wherever you see a x value, you put it in the f of x formula. So you'll
Okay, so I
substitute
put a
the
1.
minus-
I put a 1. I put a 1 where those x's are.
Well, for the first entry, you put a minus 1.
Okay, and then for the next one, you put a 0.
And the next one you put a 0, the next one you put a 1, the next one you put a 3, and next one put a 5. But remember, x appears 2 places, so you got to put the value here for the x and you've got to put it there for the 3 times the x. Got it?
Okay. Okay.
Whereas here, it only appears once. So minus 8 times x, where x is a minus 6, and minus 8 times minus 6, minus times minus will give you a plus, and you'll have 8 times 6 or 48. Got it?
Okay, I'll try.
Okay, so just substitute for the x,
That's right.
the value from the table, and then calculate the f of x. So just think of it as a y, except we call that function notation f of x.
Okay.
All right. Now you
Okay.
had some problems with the homework. Let's see if I can even look at that screen. Let's see. Homework
see that.
substitution. So let me do a new.
Okay, make sure that we save that.
And bring up the. Let's see.
Okay, I think I don't know number 2. I try with number. This is very confusing. X plus 2x2.
Okay. Can you see this screen?
Where you at, Miss Barbara?
Function and function substitution problems. This was the homework.
Yeah, see that?
Can you see it?
Yeah,
see it, yeah.
function table.
No, not function table. Let's see.
Oh, the other one that we supposed to do?
Yeah, the one you had.
No, it didn't come up.
Okay, let's see.
I can see it.
Can you see it now?
Yeah,
Mhm.
Okay, you see your homework, right?
yes, I see my homework.
Okay, so one had A, B, C. Okay? A, B, C, you had 3 parts. So for the first one, wherever you have an X, you put a -5, right? So
Where's she at? Let me see.
do you see this, Audrey? The homework?
Yeah. Okay, yes, I see it. Yes, the X,
Okay,
FX.
so yes, you have f of x equal 10x minus 3. I think you had that one right? Look, Latoya, you had that one right. So this would then be f, and what's the value? -5, right? F of -5 equal,
You're getting -5 from?
oh, A. It says for problem 1 functions, perform the indicated function evaluation. So that means when f of x is equal to 10x minus 3, what is f of -5? So f of -5,
I didn't see that part.
you didn't see this? For problem 1 functions, this is problem 1.
I mean, it's
What-
A of 5. That A. The
Well,
part that
there were 3 parts. Audrey, you had a, what is f of -5? You had a B, what is f of 0? And you had a C, what is f of 12 minus x? So one had 3 parts, A, B, C. You got it?
said-
Yeah,
Oh,
So
um,
if f of x is 10x minus 3, what is f of a -5? So f of a -5 would be 10. Now, wherever you see the x, you're going to put what? The -5. So we put -5, and that would be -3. Audrey, is that clear? The
Mhm.
substitution? Okay, so for f of -5, let me just copy that. You tell me what to write. What's 10 times a -5? Audrey, what's 10 times a -5?
10 times a -5 is 50.
Plus or minus?
Minus 3, 47.
No. What is 10 times a -5?
Oh my God.
Plus times minus gives you negative. Remember, unlike signs multiply to give you negative. Like signs multiply to give you positive. So, Audrey, what's 10 times a negative 5? Audrey?
Negative 50.
That's it. Very good. Negative 50. So that would be negative 50 minus 3. So what's that equal to, Audrey?
47.
No. Like signs, you add. So you add the negative. So it's minus 53. Okay. You only subtract if the signs are different. But see, both of these are negative. So just like you say a plus 50 and a plus 3 is 53, you say a minus 50 and a minus 3 is a minus 53. Got it?
Okay.
So any questions on number 1A?
Fx equals to 10x minus 3. So
And wherever you
there's
see an X,
negative
substitute a
5.
negative 5. So
So
f of a negative 5 is 10 times the value of X, which is a negative 5, minus 3.
And the negative 5.
Minus 50, minus 3, minus 53. That's your answer.
Minus 3 with negative 53. Mhm. Mhm.
So Audrey, what would the next one be? F of 0. Now remember, we're using the same function equation. So we take this equation and copy it here. This is B, so no C. Okay, so f of x then would be what? F of 0. Because we're trying to find what's the value of this function when x is 0. So the x will be substituted by 0. So let's put 0 there. And so f of 0, what would be the answer here, Audrey?
7, negative 7.
How are you getting negative 7? This is f of 0.
0. 10, 10,
What's
0,
10
0.
times, what's 10 times 0?
10 times 0 is 0.
It's 0. Okay, so what's 0 minus 3?
0 minus 3. Oh, God.
What's 0 minus 3?
Negative 3. It's the 3.
Yeah,
Negative
negative 3. That's right. Negative 3. So your answer is f of 0 is equal to negative 3. Wherever you had an x, you put a 0. So 10x became 10 times 0. 10 times 0 is just 0. Any number times 0 is 0. Minus a 3, so 0 minus 3 is minus 3.
Minus 3.
Questions?
Negative 3.
So that takes care of 1A and 1B, right?
F of.
And then our next one was 1C. And remember, we're still using the same function, except now our x is a 12 minus x. So we put this here. There. So f of x will be f of 12 minus x. Now, wherever we have an x, we want to put 12 minus x. 12 minus
X is
X.
10 x.
Okay. And we have, of course, our minus 3 from our original equation. Now, what would that be equal to, Audrey?
Okay, it's 10 of 12 minus x minus 3.
What would f of 12 minus x be equal to?
12. 120.
Okay, let's see. So we'll have 10
120.
times 12 is 120.
120.
That's right, 120. And then 10 times a minus x is what?
And 10 times minus x.
What's 10 times a minus x? 10 times 12 is 120. What's 10 times a minus x? Audrey?
9? No.
No, multiplication.
10, oh, 10 times.
10 times a minus x. It's just the coefficient and the variable. So it'd just be a minus 10x, right?
Minus 10.
Dots, multiply everything in the parentheses. 10 times 12 is 120. 10 times a minus x is minus 10x. Now, what is all that equal to?
Okay.
Audrey, what is that equal to? You can combine the 20 and the minus 3. And what is a 120 minus 3?
It's 117.
That's at 117. So we're combining those constants. So that would be 117. Let's take out the extra one. And minus 10x. That's your answer. 117 minus 10x. So f of 12 minus x would be 117 minus 10x. Questions? So you really substitute a variable, and we've done this before, but the thing is you did it when it wasn't a function, but it works the same. Whatever the number is given for the variable, that's what you put in for the variable. Or it could be another variable, or it could be a variable number combination. Right? Questions, Audrey? Are you clear on that?
I'm just writing it because otherwise my brain ain't remember this at all. I'm telling you.
Yeah, so you combine the like terms right here. You have a constant 120 and a minus 3, and that's how you got the 117. And of course, the 10x didn't have anything to combine with it, so you just leave it as minus 10x.
12 minus x equals 120 minus 10x.
Latoya, did you do number 2?
Minus 3.
Yeah,
You had it right?
12
yeah, I think so.
is 117 minus 10x. I know they ever be able to see the one by one.
Anyway, you see x, you put a minus 2.
That's right. Wherever you see an x, you put a minus 2. So let's just take this function, copy it, substitute minus 2 wherever you see an x. So minus 2x squared becomes minus 2 times minus 2 squared, because that was substituted for the x. The 6x becomes 6 times what? Minus 2.
Minus 3.
Okay. Now, Latoya, what's minus 2 times minus 2 squared?
2 minus 3. Okay,
Minus 2 and minus 4.
2. 2 times 2.
Okay, so minus 2 times a minus 2 is a what?
4
Negative
Plus or
2
minus?
square.
plus 4.
Yeah, this is a plus 4. So a minus 2 square is just a plus 4.
Square.
Okay, so we squared it. So let's take out the square. Okay, and now we have 2. Take out the square. We have a minus 2 times a plus 4 plus 6 times a minus 2 minus 3.
Equals negative 2, 4.
All right. So Latoya, what is that equal to? What's minus 2 times 4?
Plus 6.
Minus 8.
That's right, minus 8. So let's put the minus 8. What's 6 times a minus 2?
Minus 12.
Minus 12. So that's minus 12. Okay. And then we have minus 3. So we have minus 8, minus 12, minus 3. What is that equal to?
Minus 23.
Minus 23. Or do you follow it? Minus, 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 you add them all, minus 20, minus 23, minus 3 gives a minus 23. So minus 20 minus 3 equal minus 23. Audrey, you followed the F of minus 2? Audrey,
Yeah,
did you follow number 2?
yes,
Did you
yes.
get minus 23?
yes, I follow through with you, yes.
Okay, wherever you had an X, you put a minus 2, right? So you put a minus 2 here. Let's bring that over, okay? And you put a minus 2 here. So minus 2 by itself gives you a plus 4. And then you had a 6 times a minus 2. Minus 2 times a plus 4 give you a minus 8. 6 times a minus 2 is a minus 12. And then you had a minus 3 from the function. So minus 8, minus 12, minus 3, answer minus 23. Any questions on number 2?
Mhm.
Okay.
No,
I did that one.
Yeah,
The
you
one I
did.
didn't understand was the one with 12 minus X. That's the one I get wrong.
Okay.
Forgot the 10.
All right. Now, number 3. Yeah, you had this one right. You had 3, 4, but 5 you missed.
Huh?
You had 3, 4, but you missed 5, didn't you? Yeah, I sent you the you missed 5. You had a different answer. Oh, we'll go over it. Now for X, you putting a minus 3. So substitute a minus 3 for the X.
mhm.
Substitute, let me just put it here. Substitute
Okay, yeah, no, okay, no. Continue,
minus 3
fx
or
is
wherever you see an X, you want to put a minus 3.
minus 5
So do that,
plus 6. So
Audrey. Put the
Yeah.
minus 3. Put the minus 3 wherever you see an X.
fx equals 4
So we put it there, right?
minus 3
We put it here, minus 3.
square minus
Okay.
5.
What is that equal to? Audrey, what is that equal to?
6.
What's minus 3 times minus 3?
Okay,
Audrey, what's a negative 3 times a negative 3?
it's 9.
That's 9. So this would be a 9. We square that. Let's take that out. Take out the square because we squared it, right? And what's a -5 times a -3, Audrey?
-5
Times a -3.
-3 -5. -5 times a -3.
Like signs give you plus when you multiply.
Huh?
If you divide, when you multiply like signs, you get plus. So minus times minus gives you plus.
Minus plus.
What's a -3
Plus
times?
15.
Yes, very good. Plus 15. So that would be a plus 15. Right. Now, what's a 4 times a 9?
36.
36. Very good. So let's just copy that. 4 times 9 is 36. 36 plus 15 is what?
51.
And a 51 equal plus 6 is what?
57.
That's it. So 51 plus 6 equal 57. So our answer is what?
D.
57.
A, B, C, or D, Audrey?
D.
D. That's right. D. Okay. Any questions on number 3?
No.
No.
Okay, now let's go to number 4. Latoya, you had that one right? 4.
Yeah.
All right. Now, wherever you see an X, you'll put what, Audrey? What are you substituting for the X?
A 2.
-2.
Oh, -2.
What is H of -2? So that means when you copy this, let's just copy this and make our X a -2. So we know that whenever we substitute for the X, we put in a -2. So this is, okay. So the X is -2. So let's put -2. And the X squared, we put a -2 square. -2. Take out the X. And for the 6 minus 6X, we put -6 times a -2. So we made all of our substitutions, right? So what's a -2 times a -2, Audrey?
Is -2.
-2 times a -2.
Is 4.
That's right. So this would be a 4. So let's just put our 4 here. So so we squared it. So let's take our square off. What's a 6 times a -2?
6 times. 6 times. 6 times a -2
Yes,
is -12.
that's right, -12. So this then is -12. Okay. Okay. Now when we add this, what do we get, Audrey?
21.
That's right, you got it. Got it. Okay. 2 times 4 is 8, right? -12 minus minus is give you a plus. So that's a plus 12. And a plus 1. So 8 plus 12 is 20. And you get what? 20 plus 1 is 21.
Okay, so H is 2.
Plus 12 is 20. Plus 1 is 21. So what's the answer? Oh, this, I sent you a,
H is 2.
this should be C.
Equals 2.
And this should be D. I sent you a correction on that one.
6.
Should be A, B, C, D.
Negative 2. Plus 1.
So that's a 21. So answer
2.
C.
Yeah, I get that one right.
Answer C. You had that one right. But Latoya, you didn't have number 5 right.
12.
I think you had 33.
Yeah,
You got 30.
I know where I get that from.
Oh, you know?
I don't know.
No,
I was half asleep.
no, I thought you said you knew where you got it from.
Equals 4x2.
Yeah, I did 33. I don't know. I couldn't. I think I got it mixed up with something. I don't know what I did wrong.
Yeah, I think your signs. I think it was your signs. Because if you make a mistake on your signs, you will get that.
It's wrong. Period.
Yeah, you get that wrong.
Once the answer could be right, but if the sign wrong, it's wrong.
That's right.
You don't get credit for signs.
No, you don't. Okay. So let's see. That's fine.
I really think I didn't. I don't know if I did it. Does it look unfamiliar to me? I don't know. I don't think I did that one.
You had an answer for it. I think you had 33. Let me just look. You text me.
I don't know.
Let me just check.
H2.
Okay.
Because when I printed out the came,
You
I didn't see this.
you said number 5. You said C, and C is 33.
Oh, it looked familiar. I didn't even know see A. I thought it was a different. That's
Yeah,
why
you
I
had
said
answer C. You had answer C, and let's see how you. Okay, Latoya, let's do it. G of A is 2a to the third minus 6a squared plus 1. So let's just copy that and substitute in for A, -4. Okay, so let's copy this.
there's no way could I get 33 because I told you
But
I
you
had
put
this thing
C.
wrong. Yeah, I had that. I didn't see it. I know I did something wrong because I don't know what I did wrong.
Okay, let's just put in the values. A is a -4.
G -4.
Okay, so we got that -4. And that's to the third power. And this we have A again,
Mhm.
-4.
2.
And that's to the second power. Okay.
Third
Now,
power.
remember, just a hint, whenever you raising something to the third power, you'll get really the sign of the number. So if it's a minus, then the answer will be negative. But if it's to, if it's raising to an odd power, to an even power, you get if it's a minus, you get a plus.
Yeah.
So that means then, let's just copy this. And Latoya, you tell me what you get here. -4 to the third power gives you what?
64 minus 64.
Okay, so that's a -64. Or do you follow in 4 times 4 is 16 times 4 is 64. So that's 64. All right. So that's raised to the third power. Now, what about the -4 to the second power? What is that, Latoya?
Minus 16.
-4 times -4?
Oh no, 16.
16, right? Not a minus. Minus times minus give you plus. So that would be 16. So we squared it. And let's take out the square. All right. Now, what's 2 times a -64?
Minus 128.
Okay, so here we go. That would be a -1.
128, yeah.
Minus,
16 plus 1.
so -128.
4 minus 2, 24.
What's a -6 times a 16? Latoya?
Minus 96.
That's right, -96. So when you add a 128 and a 96, what do you get?
224.
224,
Plus or minus?
223.
plus,
223.
no, minus.
What do you get, Audrey?
223.
Yeah, but you have a minus. Latoya, you just said it,
Negative
right?
223.
Yeah,
That's
minus
right.
223.
Negative
223.
224. That's a negative 224. And a
Plus
plus
one.
1. And that gives you a negative
Negative
223.
223. Mhm.
Now, Latoya, I don't know how you got the 33.
I got the 126, man. I got the 128 minus 96, and I don't know what the hell happened from there.
You did sleeping?
Yeah, what happened?
No, I think what happened is, you know what happened? You put a 128, you put a plus, right? And then that would have given you 32, and then plus 1 is 33.
Yeah, I did that, yeah.
That would give you the error. If you made this 128 a plus,
Yeah, I think I had
and a plus 128, 129 to subtract the 96, you get the 33.
That's exactly what I did, because I know I get everything just right, but that
That's
time
right.
was messed up.
That's what you did. That's exactly what you did. You didn't have a negative, you put a plus. And that would give you the 33. Okay. Audrey, is that clear? Number 5?
Yeah.
Yeah, you got it.
Yeah, you gave me the answer. Okay. Now, let's look at number 6.
This
Number,
one I didn't understand.
oh, you didn't understand number 6?
No, I was on it for hours. I didn't understand what they have to do with
Okay.
it.
Number 6. Okay. Audrey, did you try number 6?
Yeah.
Now, notice you had a f of 3 and you had a g of 3, but you were
Yeah.
given a f of x and a g of x. Now, let's just take the f of x first
So it's an F of 3.
and then do a f of 3, right? So we have a f of x is x squared minus 2x plus 8. There we go.
So small.
Yeah, I know. I'm going to make it bigger. Okay. Now, we want to substitute. Okay, substitute. And it says f of 3. So substitute 3 for x. So just take this function and wherever you see an x, put a 3. Just copy that.
F is 3.
Okay, so we have f of 3. So there we put the 3 in our function. And then the x squared would be 3 squared minus 2 times
2
3.
times
There it is
3
again.
plus 8.
That's right, plus 8. That's right, Audrey. What's 3 squared?
9.
Okay, so let's just copy that and put our 9 here. So 3 squared is 9. 3 times 3 is 9. What's 2 times 3?
6.
2 times 3 is 6. So that's a minus
8.
6,
Plus the 8.
right? And so f of 3 is what would be the answer?
And that's 11.
That's it. That's your answer. So you got the f of 3. So 9 minus 6, and that would be equal to 3 plus 8 equal 11. So that's the f of 3. Now we'll go to our g of 3. Latoya, did that answer your question?
Yeah, I guess so. This one I didn't understand it at all.
But what about the f of x, the f of 3?
So what you do with the
Now we go to our g. It says
so you
f of,
get 11.
that's
So you
for
put the 3.
f of 3.
Oh, so you get the 11. Let's say you get the 9 and the 6.
Audrey,
There you go.
explain how you get 11.
And add the 8.
9 minus 6 is what, Latoya?
3.
And 3 plus 8,
Oh, 11. Oh,
11. Okay, so f of 3 for f of x equal x squared minus 2x plus 8, that value is 11. Now you go to your other function, g of x.
yeah, that was what I didn't understand.
Okay, so let's take this one. That one has a radical in it.
What was that, Miss Barbara? If it mess it up with radical? Oh.
Oh, you know radicals.
No, I don't. The regular function
Audrey,
is in me.
Audrey, you know radicals, right?
A little.
Okay, so wherever you see an x, you want to put what? A
3.
3.
Yeah.
So let me just copy this. And wherever I see an x, I want to put a 3. So let's just copy that. Okay, so that's g of 3. Let's put the 3 here, right? And underneath our radical for the x, we put a 3. Right?
Yeah, that part I did, but what to do with it, I don't know.
Okay,
You
now,
multiply it and you get 9.
well, 3, you add it and get a 9, Audrey.
Well, right.
It's-
And then you
add.
6. Yeah, you add the 3 and yes.
So g of 3, let's just put that here. We add the
Cause it's
6
3
to the
threes.
3.
3 times 3.
That would be the square root of 9. So let's just put 9 here. And what's the square root of 9?
3.
3.
3. That's your answer. That's your answer. G of 3 is 3. Because we put the 3 in for the x, adding the 6. We got 9. 9 is a perfect square root. 3 times 3 is 9. So g of 3 is equal to 9. Questions? Questions? Latoya?
No, I understand that part. Oh,
Now
boy.
it's that, see, the whole thing is underneath the radical. So g is x plus 6 underneath the radical. So when it's a 3, 3 plus 6 is 9. Square root of 9 is 3. And that's your answer.
But not all the time it's a perfect square.
No, it's not. It's not always the perfect square. Sometimes you have to break it up into 2 radicals. One may be a perfect square root and one may not. Sometimes it's a negative and you've got to use the -1 square root, which is the imaginary number I. I think we had one like that. All right. Now we have another f of -10, g of -10. Now that's using the same equation, except now we're saying f of -10 and g of -10. So let's just take this, wherever you see an x, you're gonna put a -10. Wherever you see an x, you want to put a -10. Like that here. Okay, so put a -10 right here, -10 for the x substitution. Put a -10 here, so that's a -10 squared. -2 times a -10.
Okay. This is 10.
Wherever you see an x, you want to put a -10.
And 2. This is 10.
Now let's just see, let me just bring that.
Square. I have a number.
Okay,
Where's she gone?
so what's a -10
Where's she
square,
gone?
Audrey?
-10. -10 square. 20
Take-
minus 10,
No, what's 10 times 10?
100,
Okay, so 10 times 10 is 100, so that's what? A minus,
10, negative 10, 10.
actually, let me put this in parentheses, because it's the minus 10 squared, all right? Okay, so let's just copy this, and the minus 10 squared you said was 100, right? So C is here, and minus 10 squared is 100, that's 100. Okay, what's minus 2 times minus 10, Audrey?
Huh?
What's a minus 2 times a minus 10?
Minus 2,
Times a minus 10.
minus 2. Minus 2 times a minus 10 is
Yes,
20. It's 20.
that's right, a plus 20. And then we have plus 20 and a plus 8. So what's 100 plus 20 plus 8?
128.
That's right, so that's your answer. 1, 2, 8. That's the answer for your F of minus 10. Then we go to our G of minus 10. So let's go back up to our G. Again, that's the G of X. So we'll copy that and put our minus 10 for the G. Okay, so let's put our G here. It's bigger. Okay, now wherever you see the X, you want to put a minus 10, right? So put a minus 10 here. And put a minus 10 here. So you have a minus 10 plus 4. What is that equal to?
Plus 6.
Minus 10 plus 6 is what?
A minus 4.
Minus 4. So this will become G. Okay, let's put this here. So this
Oh, I get
becomes,
137.
for this one, 128.
Yeah, 137.
I don't know, Latoya, you must have been tired. This is a minus 4.
God.
Okay, so we have G of a minus 10 equals square root of negative 4. Now, negative, when you have a negative number, what you do is divide it into a negative 1 and a number. So what two numbers would I put on the square roots to give me the negative 4?
2.
2. 2 and 1.
No. I need something
4.
with. Who said 4 and 1?
I said 4.
4 and 1, right. So this becomes, let's put this, and I'll copy this. The square root of negative 4. Now, okay, now I can make this a plus 4 times the square root of a negative 1. Okay? Because remember, you can break up radicals into other radicals, right? So a square root of negative 4 is a square root of 4 times the square root of negative 1. But a square root of negative 1 is equal to the imaginary number I. So let me just put this here. That's something for you to keep in mind. Whenever you have a negative 1, that's equal to I, small I. Okay, that's imaginary. if you have a negative square root, break it up into two square roots where one has a perfect square root and 4 does have a perfect square root. It's equal to 2. And the square root of a -1 by definition is I, the imaginary number. So what does this become? G of -10, let's copy this here, is equal to square root of 4, which is 2. So this would be 2 times the square root of -1, which is imaginary. So just be 2i. So that would be your answer. 2i. Questions?
I had the imaginary one. I
What?
did the last part, but I didn't know how I get there.
Oh, okay. So a negative number is an imaginary number. In imaginary mean it really doesn't exist, right? So that's why we just put I for the imaginary. So if you have a negative number, what you try to do is break it up into 2 parts where one has a perfect square root and the other one has a -1. Okay. And the -1's, the square root of -1 by definition is I, an imaginary number. So G of -10 is 2I. Questions? Now, f of 0, now we go back to our same f function, f of x. And what is f of 0? Audrey?
0.
We're taking this f of 0. Okay, so let's just put here, wherever you see an x, you're going to put a 0. So let's see, this is. Okay, so this becomes, wherever you see an x, put a 0. And you can see what the answer is going to be, right? What's the answer?
8.
Okay, so f of 0, wherever you see an x, put a 0. So you put a 0, 0 squared is just 0, right? 2 times x is 2 times 0, which is just 0. So what Latoya said is right. 0 minus 0 plus 8 is equal to 8. That's your answer. F of 0 is 8. Now, the last one, f of t. Same.
Did you see that one?
D, you didn't see D, f of t?
No.
Yeah, it was there.
Oh, God.
I guess it hid from you. Okay, f of t, which means every time you see what, an x, you're gonna put a t. So let's just, okay, so let's just copy. Now, wherever you see an x, put a t. So put t, right? X squared becomes t squared. 2x becomes 2t. That's it. You could just leave it just like that. F of t is t squared minus 2t plus 8. We don't go into solving the quadratic, all right? Just leave it as t squared minus 2t plus 8. Any questions?
And these are hard.
All right. Now, in some cases, they want you to factor it, but you didn't have to factor this one. You just leave it, substitute the t for the x, and leave it this way. Now, if you were given multiple choice where you had factors, then you would have to factor this to get the answer. Any questions on anything we went over?
Yeah, I think I need that one because.
So you think you're better prepared for substituting now?
I guess so.
Because that table that I said, those tables I want you to finish, that's substitution. So that'll give you some practice because your homework would be to complete that table. And you're given the input and you define the output. So that's substituting. And that's what we did here. Because when we said G of 0, F of 0, that's the output. What is F of 0 when X is 0? Okay.
This function is like, I don't know.
What?
This function is beating me.
No, are you doing good? Audrey, is it clearer?
Sort of.
Sort of. I
She
think,
said something.
well, try those tables. I'll be sending you those for your homework, okay? Complete
So you
those
see
tables.
wherever the X is, suppose you have 2X, you have to multiply it by the input.
If you have 2X, you mean from the tables?
Uh-huh.
Yeah.
Where the X is.
Yeah, where the X is, if the output has 2X, that means you might have to multiply 2 by the value of X in the table. So remember, you have several values in the table. So for every value in the table of X, you want to find a Y. And the Y here is called F of X. Okay, so that's what you're finding. You're finding the output given the input.
So Fx will be the table.
Yeah, F of X is the output.
Right, the output.
X is the input.
And X is the input. Okay.
That's right. Now let's see if I.
So whatever is on, whatever numbers are on the input side, you multiply by the output.
Well, let me just
X.
let me do a new share. Okay, you see this function table?
Yeah.
Okay, so the F of X is the output. That's what we've been calling Y. That's the output. The X is the input. So to complete the table, you take the equation for the table, plug in the input, and solve for the output. So 2X becomes 2 times a negative 1, right? 2 times a negative 1 is a negative 2. Add 13 to that, and you get F of X, 11. Is that clear, Audrey?
Where is that? I didn't see that part.
You don't see the function table?
Yeah, I see the function table here.
And you see F of X equal 2X plus 13 for number 1?
No, I see that. Okay, let me see. I don't know where you at. Okay, yes,
see the
all right. I
function
got the
table?
tables now.
Okay, so F
Okay.
of X is 2X plus 13, right?
X is 2X,
So,
yeah.
so for every value of X, you want to find the F of X. So the first one, you put a -1 for the X. 2 times -1 is a -2. Add the 13 and you get a plus 11.
1.
So F of X would be 11. Got it?
Okay, so that's 2
Audrey,
times.
is that clear?
Yeah, I
2
think
times
so.
a
2
minus
times
1 is a
plus the
-2.
13.
And add the 13 and you get a
Mhm.
plus 11, right?
Okay.
Now, if you change your input, the table now says 0. So 2 times 0 is just 0. So 0 plus 13, so F of X is 13. Got it?
Okay, so the X that is next to the equal sign is what I will be multiplying the numbers in the left column, which is the output.
That's right. That's the input.
Okay. Okay.
X is the input. You're solving for the output. So
Okay.
you're plugging these values into the X, and all these are X, right? And then you're doing the math and then put the output in the F of X. Got it?
Okay. Yes.
All right. Latoya, you okay with that?
Yeah.
Okay. So that will be your homework. So I'll be emailing that to you. Okay.
Okay. All right. Send it before my brain stuck.
Okay. No, I'll be sending you
Send me
this.
your brain is freezing on this, Barbara.
What?
You know, you be studying and studying, thinking, then your brain freeze.
Yeah, that's right. They call that the
Yeah,
brain.
that's
They
true.
call that the brain freeze too.
Yeah.
Even when I'm
Um,
writing, my brain freeze sometime. I'll be like, I gotta take a break.
Yeah, you take a break. You take a break, do something to entertain yourself, look at a
Yes, you gotta do
movie or
that.
something, and then come back to it. But I just want to make sure you understand you substituting the input from the table, calculating the output. Substitute
Okay.
the
I'm
input from
sorry.
the table, calculate out. Yes, Chastity.
You said the input is the X, right?
Yes, the input is the X, the output is the F of X.
The F of X.
And the
And the
F of
relationship?
X is in the equation. The output F of X for this number 1 is 2x plus 13. So wherever you have an X value, you put it in to the equation and calculate the output. So the first one I was saying, Chastity, -1, 2 times a -1 is a -2. Plus a 13 will be 11. So that first entry for F of X would be 11. You got it?
Okay, and which is the relationship?
Relationship is this F of X equal 2x plus 13. The output is related to the input with this equation, all right? And each time you change the input, you get a different output, because now if it's a 0, 2 times 0 is 0, and 0 plus 13 would be 13.
13.
You got it? And if it
Yeah.
were 1, 2 times 1 is 2. And what's 2 plus 13, Chastity?
15.
That's it. So F of X is 15. What about when it's 2? What would F of X be?
When it's 2?
Yes, when X is 2, what is F of X?
Is it X?
2 times 2 is what?
Oh, 2 times 2? 4.
And 4 plus 13.
17.
That's it. So that would be, you put in the table, 17.
Okay.
When it's 5, 2 times 5 is what?
15.
2 times 5?
2 times 5?
Yes.
10.
10. So 10 plus 13 is what?
23.
That's it. So you put 23. So you take the same equation, take your input values in your table and calculate your output.
All right.
So
Thank you
wherever
so
you
much.
see the X, you're looking at this column, right? All your X values are in this column. You're calculating these Y values, which we call F of X. And you're using this relationship to do that. And then when you get to number 2, you have a different relationship. You're squaring the input, adding it to 15. So this one, -2 times 2 is a +4. Added to 15, F of X would be 19. You
19.
do that for the rest of them, okay?
All right. Thank you so much.
All right, Audrey, still making sense?
Yes.
Okay, all
I
right.
got my
Okay,
mail.
thank you.
Thank you.
So Ms.
Okay.
Barbara, it's not, it's a -2 square plus 15?
-2 square, -2 times itself is a +4, right?
Yeah.
And a 4 and a 15 would give you 19. So that first F of X is 19.
Okay.
Got it? And if
Yeah.
it's 0, 0 squared is just 0. So F of X is 0 plus 15 or 15. Got it? And
Okay.
then 1 times itself is 1. 1 squared is 1 plus 15. Then F of X for X of 1 is what? 16. Got it?
Yeah.
Okay. Thanks for joining, and I'll be sending you this right out. Okay. When we
Okay.
Can you email it to me? I mean, not email it. Can you mail it to me?
mail it, yes, I'll mail it to you.
Thank you so much.
Okay. All right. So long, everybody.
Thank
So
you.
long.
Good
Thank
evening.
you.
Enjoy the rest of your week.
Okay.